Hey everyone, and welcome. We're about to dive into something that honestly sounds like it's straight out of science fiction. But believe it or not, it's becoming real and way faster than you might think. We're talking about the next massive leap in technology, quantum computing. So think about this for a second. What if a computer could solve a problem in the blink of an eye? A problem that would take our absolute best supercomputers, the ones that fill entire rooms, literally thousands of years to crack. That is the absolutely mind-blowing promise of the tech we're going to get into today. Alright, so let's kick things off with a new computing frontier. We're going to get right to the heart of what makes this technology so completely different from anything we've ever seen before. So right at its core, quantum computing uses the super strange rules of quantum mechanics to get these exponential speedups for really specific, really complex problems. And the key thing to get here is that this is not just a faster version of your laptop. Not at all. It's a completely different beast, operating on a whole other level. It uses those mind-bending rules of the quantum world to go after problems that are just impossible for the computers we use today. Okay, so let's move beyond the binary bits. We need to talk about the one thing, the core component that makes all of this possible. And trust me, it's a world away from the computers you and I use every single day. Alright, so let's break down the fundamental unit here. Every computer you've ever used, from your phone to your laptop, runs on what we call bits. And a bit is super simple, right? It's either a 0 or a 1. That's it. But a quantum computer uses something called a qubit, and this is where things get wild. A qubit can be a 0, it can be a 1, or, and you gotta love this, it can be both at the exact same time. That one little difference, that's the secret sauce. That's where all the power comes from. So you might be asking, okay, a qubit can be a 0 and a 1, so what? Well, that's where we get to the quantum superpowers. This ability gives quantum computers two incredible advantages that normal bits could only dream of. Okay, superpower number 1, superposition. This is the ability of a qubit to be in multiple states at the same time. The best way to picture this is with a spinning coin, right? While it's spinning in the air, is it heads or tails? Well, it's kind of both. It's in this blur of all possibilities until clink, it lands and finally picks one. A qubit in superposition is exactly like that spinning coin, holding on to both 0 and 1 simultaneously. And this is why that's a game changer. This allows quantum computers to perform a massive number of calculations in parallel, not one after the other. Think of it like this. A normal computer trying to solve a maze would have to go down one path, hit a dead end, come back, and try another one at a time. A quantum computer, thanks to superposition, it basically gets to explore every single path in the maze at the exact same time. That massive parallel processing is where the mind-boggling speed comes from. Now, if you thought that was weird, buckle up for the second superpower, entanglement. This is where qubits get linked together and the state of one instantly, and I mean instantly, affects the other, no matter how far apart they are. We're talking across the room, across the country, it doesn't matter. Einstein himself calls it spooky action at a distance, because it's just that bizarre. But this spooky connection is what lets them perform these incredibly complex, coordinated calculations. Alright, so we've got these cool superpowers, superposition, and entanglement. Thank you. But what's the point? What can we actually do with them? It's time to start solving some impossible problems. Let's talk about why all this actually matters in the real world. And one of the first places we're going to see a revolution is in medicine. Seriously, this could have a life-changing impact for all of us, especially when it comes to discovering new drugs. See, right now, creating new medicines is a really slow, painful process of trial and error in a lab. But what if you could perfectly simulate how complex molecules behave, right down to the atomic level? That's exactly what quantum computers are built to do. We could stop the guesswork and start designing new medicines with incredible precision. This would drastically speed up the development of new drugs and even help us create personalized therapies designed just for you. And it's not just medicine. This tech is poised to create smarter systems across the board, from AI to the logistics that get packages to your door. I mean, just think about global supply chains, finding the absolute most efficient route for millions of packages flying around the world. That's a puzzle so huge our best computers can only get close enough. A quantum computer could find the perfect answer, And it's the same idea for things like supercharging AI training or designing brand new materials for, say, way more efficient batteries or better solar panels. And this quote here really just nails it. Quantum computing has the potential to solve problems deemed intractable for today's supercomputers. The keyword there is intractable. We're not just talking about an upgrade. We're talking about opening the door to solving problems that right now are literally impossible. Okay, this all sounds absolutely amazing, right? But we have to take a breath and talk about the road to reality, because building and running these things is, well, incredibly difficult. Yeah, harnessing this power is insanely hard. It turns out the very things that make quantum systems so powerful also make them extremely fragile. I'm talking the tiniest vibration, the smallest change in temperature, anything can throw the whole thing off and ruin the calculation. So yeah, these superpowers, they come at a cost. And just look at the practical differences here. Your classical computer, your phone, works just fine at room temperature. A quantum computer, it has to be kept near absolute zero. That's colder than deep space. And because they're so sensitive, the error rate is still pretty high, which means you need all this complex error correction that engineers are still working to perfect. It's a whole different ballgame. So to build one of these things, you need some serious hardware. We're talking a core chip made of superconductors or trapped ions. You need these massive cryogenic cooling systems just to keep it stable. And then, you need incredibly precise electronics to zap the qubits with microwave pulses to control everything. It's this beautiful, intricate system that looks like a tiny chandelier, all housed inside a giant super cold fridge. So the big question is, when is this actually going to happen? Well, things are moving really fast, but the general feeling is that we'll start seeing mature, commercial, large-scale quantum computers sometime around 2035. So, we're still in the early days, but the destination is starting to come into focus. And that leads us to one last really big idea to think about. Quantum computers are kind of a double-edged sword for security. On one hand, they'll almost certainly be able to break the encryption we use to protect everything today. Your bank accounts, government secrets, you name it. But, and this is the fascinating part, they also give us the tools to create brand new, completely uncrackable codes. So it can break the safe, but it can also build